Hello, and welcome back to Learning with Lee. In today's episode, we are going to be taking a look at classes and how you create a class, as well as how you delete a class. In the previous episode, we initially examined how classes are different than structs, and we didn't do a fully comprehensive coverage of their differences, and that's going to be really the topic of the next several lectures so that we can begin to understand why classes exist. We have a general idea for why they do. However, there are a few differences throughout here. And the next thing we're going to take a look at is this new link function. Well, now it's a method or member function that we ended up not really taking a look at previously due to the fact that it is a bit special and different. And that is that the way in which you create a class is a bit different than how you would create a struct. Previously, we had to go through mallocing something that was the size of a struct. And with a class, there's a new way of actually doing this. And what you do is rather than having all of this over here, you can delete all that. And what we can do is we can go with new link. And there's a reason why I had named this thing new link here. And technically I would have to do in this case here because I could do link-over-reset. And right now this actually is still a function. It's not a member method. And the reason why it still is treated more or less as a function is that right now I'm not actually using it to generate this link in particular. And the whole reason for that is that you see this one right here. And this one over on the right-hand side happens to be what's known as a constructor. And it's basically what it does is it allows, and every single class has a default constructor provided for you by the compiler. Now you can end up overriding this in your class, and we'll get into how you do that in a little bit. However, for now, what this happens to do is it goes, I need a certain amount of memory to create this particular class. And it's going to allocate that memory for you. Now, this new keyword happens to mean that I'm going to get back a link pointer out of it, rather than just something that's on the stack. It's going to create something on the heap for me, similar to if I had done malloc, except it handles all of the malloc side of things for you. So, the alternative for what I could do here, and this is something that really doesn't work in this case here because I'm returning it, and this would be a local variable on the stack, is I could do link, and I would have to link.reset, because of the fact that this one here is not a pointer, but rather happens to be similar to a struct. So that's really how you end up creating it using the default constructor and the like, or either this way here, where you just do link, and that doesn't really give you some of the other stuff, or you can do equals new link, and then you have to do the parentheses after it, except this one here, it's not returning a link, it's returning a link pointer. And then I have to do this. The easier way to do this is we can override what the constructor is, and that's part of why I named this thing new link. And the way in which you do that is rather than dealing with any of this, all that you do is and this can be both public or technically you could do it protected or private, or we'll get into how you do what are known as internally protected variables in the future. But for now, what you can do is do link with an int value. Alternatively, you could have a default constructor in case you want to override the initial one and just have it be this itself, in which it happens to have the empty parentheses. Alternatively, you could effectively override the default constructor by having link value equals 0. And this would end up allowing you to have it work for both in case you did a new link this way or if you supplied a value to it. However, in the event that I provide my own custom constructor, such as this, then the compiler will not provide a default constructor for you. So I won't be able to do this once I go to build it. So as a result, I have to provide it a value. I can't just give it this new link. And that's what we want it to do. We don't want it to be, you can just create a link without having some value stored in that link. So what we're going to do now is change this one here So as before, we just do similar to a namespace where we do the link : before the name of it. For this, we don't even need a return type on it. And then we want this. So we don't need it to return anything down here. We don't need it to create a new link, since this will basically as part of the constructor, it will do that for us, because you have to remember that we are existing within the context of an instance of the class link. So at this point here, we have a particular one. So we can just do reset, and we can do item equals value without having to do any of these null checks, without having to do anything else like that. And it's much shorter, much more condensed, much simpler. And that's really all you have to do in order to convert how we had it before for how you created one to how you do one now. Now we're going to have to change the spots where we're using it so that it uses a new link rather than calling the function new link. So let's head on over to our linked list sort, as well as we're also going to have to do some stuff in the linked list. So first in here, well, you can see the problems here of what I then have to do actually. And this is something I did not do in the previous ones. I did not change it around so as that I have to then get it so as that link removes links. And then let's see some of the other errors. Ah, yes. So in this case here, what we end up doing, or what we can double check over here, is how we do our insert. So it takes in the link pointer next. So what we want to do is we want to copy this one out here, because basically we're in the context of item, and we want the next pointer as described by here, and do that there. Same thing for down here, where we'd end up doing it. We would want new item, and then get insert and do that, and so on and so forth up along here. The major thing then is that for things such as this new link up here, that's going to be somewhat different. And it's actually going to be somewhat easy to deal with, because we just have to go with putting a space between the two of those. It's part of the reason why I had named it new link is all one word, is that the only change that was required was me putting a space between the keyword new and the name of our class, which is link. And then that fixes that portion of it, and that takes care of our errors in here. And actually, I don't believe that we're actually going to have to do anything in here, so yes. That takes care of that section for us. However, there's an important thing to understand. When you use the new keyword to create a class, because it ends up using the heap, similar to malloc, you need to eventually free that memory. However, we don't use free to actually do that when we're dealing with classes. What we do is we use delete. And delete happens to be another function that's provided for you that takes care of cleaning up a class. And there's some additional things that we could end up doing with this in order to further make it a bit more intelligent for how links get deleted, and the way in which that is known as destructors. So let's quickly convert our linked list up here to use constructors and destructors. For starters, we need to move up the new list function and turn it into a new list method, in which in here, for now I'm just going to have everything be public so as that the rest of our functions and methods don't get completely destroyed by me making these three down here private. So we have this, and what we can then do is we can go list, and we can just leave that alone for now. Oh wait, except we actually need to name it linked list, because that's how it ends up knowing. It has to have this, when you use a constructor, it must have the same name as your class. So you can't just name it like list and not have anything else there, because then it's going to assume that you're missing some type in front of it to specify its return type, because it thinks it's a method, not a constructor. So what we then do is we can head on over to linkedlist.cpp, and I'll just move that guy up here. Find new list, and we can just change that on over so that now it ends up using a linked list. So that, and that's all that we really need to do. We don't need any of this in here for it. We don't need the check for null. we don't need the return statement, because all of that gets handled for us by the compiler when doing this. So that makes our life a lot easier. Then over in here, what we need to do is count equals 0, first time is null pointer, and then we can do this comparison in here for dealing with this. And for now, it still is using function pointers, and that's perfectly all right for how we're going to be doing this in the long run. But for now, let's just focus on how we're doing the constructors and destructors. So this is how we would construct a linked list. And therefore then, the couple of places where we end up using this actually still works just fine for doing this, because it ends up using this constructor. Well, actually, it will give us, I believe, an error. So what I can do then is pass in list, and then give it its comparison. Well, actually, for that one there, what we would have to do is equals greater than. So that would be the way of checking that our previous list, if it used greater than, we could do that. Alternatively, and just for simplicity's sake, so as we can do this without having to worry about it, because of the fact that we're going to be assigning that later on, I'm going to also create a linked list default constructor, or actually, an easier way to do it, we're just going to say equals true by default. So by default, that's going to be true. So then, let's say that I want to clean up my linked list, which is something else I'm going to have to do, but let's just make certain that, yep, up here there's an error. You can see the little red square over here, which tries to do that. And I can do this, in which then it needs to be a linked list. And there we go. And that's really all that we need to change for that. But now, for when I want to destroy this linked list, previously I was having to go through this whole delete list function that is here and is down here. And right now what we can do is we can just flat out remove that declaration there. And what we're going to be doing instead is we are going to use a destructor. And what you do is use tilde followed by the name of your class. And in general you want these to be, when you declare them and the like, to be up at the same spot where you end up having your constructors. So you want to typically do your constructors, then your destructors. So as basically you can sort of have a visual representation that how you're creating and how you're destroying it are intrinsically linked. And a default one is once again provided for you, but the important thing here is that you see all of this that we end up having to do. And we don't have to actually deal with free list anymore, because that gets handled by what you'll see is, you'll see how I named this delete list. There's a reason why I chose the word delete. And that's because that happens to be a keyword that will eventually end up calling this. So we actually don't need that bottom free. And what we can do instead is we can use, and once again we have to prefix this with the name of it, and then in here, tilde, oh, so that's because I had those over there, linked list. And this will end up working for our destructor. And what we'll want to do is, well, technically, well, I can change this so that it ends up using this pointer, so as that the pops end up working correctly. Because otherwise, I'd have to change pop to be a member method, which is something that I'll do in the next episode. But for now, that's how you end up making the changes for your destructor to actually handle dealing with this linked list. However, now we need to change in here because there isn't this option here. So what we instead do is we go with delete space list, and that will tell it to end up destroying that item. Alternatively, as I did in the other side, you can put parentheses around it, and that's okay. And that will be how you end up creating and destroying objects and classes. And it's important to understand that you honestly don't need this thing unless you have anything within your class that also needs to either be deleted, or if it needs to be freed because it's dynamically allocated memory, When we get into files, in case you have any files that you're currently using, you need to be able to release those files so that other programs can then use them. So those are all things that you'll want to take care of in your destructor. In the next episode, we'll get into how we end up converting these into member methods of linked list, and what the differences between how they currently are implemented are and how they will be implemented. And I know that it's going to be a bit redundant with the previous episode, however, at the same time, a bit of having that redundancy there will be a good thing, just so to make sure that we have a good, solid understanding of how classes and objects work, different from how structs used to work in C before C++ came around. Thank you very much for watching. I hope you have a wonderful day.